Okay, so now we got to talk about spin. And what is this thing called spin? Well, spin is entirely a quantum mechanical phenomenon. Right? It has no classical analogy that is accurate, that is correct. Spin is intrinsic angular momentum. It is angular momentum that is built into your particle. It's part of the nature of the particle. Electrons have spin. All right? Where does the spin, how do you see the spin? Well, if you solve the relativistic Schrodinger equation, which we didn't even write down, if you solve that equation, as Dirac did, well then one other quantum number drops out, and that's the spin quantum number. And that spin quantum number we call m sub s. Right? And m sub s has two allowed values. It can be 1/2 or it can be -1/2. So here we have a quantum number that's not an integer. All right? So it's 1/2 or -1/2. Now, what students often like to do is to think about spin as a classical analogy whereby if you have some electrons, so this is my electron here, and it's spinning around its own axis, right? The angular momentum vector is perpendicular to that plane, and if it's spinning in this direction, you might call this spin up. But of course, if it's spinning in the other direction, and then the angular momentum vector is again perpendicular to that plane, hey, you might call that spin down. Okay? This is a classical analogy. That is not correct. The electron isn't rotating around its own axis. But if it's going to help you think about that right now, okay, just remember, it's not really correct, all right? Because this idea of spin is intrinsic angular momentum. It's part of the nature of the particle itself.